Now I am going to explain about Norton's theorem. Okay, this is the normal circuit diagram to calculate load current. Okay, by using Norton's theorem, step 1 we need to calculate Norton's current. Step 2 we need to calculate Norton's equivalent resistance. Step 3 I need to calculate load current by using Norton's equivalent circuit. Okay, that means we need to connect 4 circuit diagrams. Okay, first of all we will connect this circuit diagram. Okay, for these connections, first RPS positive is connected at one point. Okay, RPS positive is connected at one point. At that point, 1.8 kilo ohm resistor starting point is connected, right? It is 1.8 kilo ohm resistor starting point is connected. Okay, next this 1.8 kilo ohm resistor ending point is connected at another different point. Right? Different points will be connected in horizontal lines. Okay, at this point another 1.8 kilo ohm resistor is connected. Okay, now this 1.8 kilo ohm resistor is connected to ground. Next, at this point only another 1.8 kilo ohm resistor starting point is connected. Next, this 1.8 kilo ohm resistor ending point is connected at another point. You can see here this 1.8 kilo ohm resistor ending point is connected at another point. Okay, at this point ammeter positive is connected. Now see here, this is ammeter positive. Okay, at 1.8 kilo ohm resistor ending point ammeter positive is connected. Okay, next ammeter negative is connected at another different point. Okay, next at this ammeter negative point load resistor starting point is connected, right? Next, load resistor ending is connected to again ground. Next, RPS negative is also connected to ground, right? Ground is having 3 wires. Yes, now connections are over, right? Okay, next coming to the procedure. Okay, next coming to the procedure, connections made as per the circuit diagram, right? Switch on the power supply. Okay, switch on the power supply. Now you can observe the theoretical calculations. For 15 volts, IL value will be 2.03. For 20 volts, IL value is 2.7. For 25 volts, IL value is 3.3 milliamperes for this first circuit diagram. Okay, now we need to verify practically, right? Okay, see here, by varying the RPS voltage in steps of 15, 20, 25, note down the corresponding ammeter reading, right? Right, set RPS voltage to 15 volts. Right, 15 volts. Here theoretical value is 2.03, practical value will be 2.04, approximately equal. This is for 15 volts. Next, similarly vary the supply voltage to 20 volts. Vary the supply voltage to 20 volts. Then current will be, theoretically it is 2.7, practically it is 2.72. Yes, verified, right? For 20 volts also. Similarly vary the supply voltage to 25 volts. Note down the corresponding ammeter reading, right? Here 3.3, here 3.4, approximately equal, right? Theoretical and practical calculations are verified for 15 volts for IL circuit diagram, right? Okay, next after that reduce RPS voltage to 0, right, and switch off the power supply. Okay, after that see here from the second circuit diagram, here I need to calculate Norton's current. To calculate Norton's current, remove the load resistance RL. Across those two terminals, I need to connect a ammeter, right? That means here I am removing the load resistance RL. Okay, this is ammeter positive and ammeter negative, right? Okay, at 1.8 kilo ohm resistor, starting point again ammeter positive and ammeter negative is connected to ground. Okay, that means across these 2 points here I can connect a ammeter, right? Now connections are over, right? Connect the circuit as per the circuit diagram, right? Switch on the power supply. Okay, by varying the RPS, okay, by varying the RPS in steps of 15 volts, 20 volts, 25 volts, note down the Norton's current reading, right? Right, 15 volts. See here, theoretical value will be 2.78 milliamperes, right? Here practical value is 2.78. Okay, similarly for 20 volts, for 20 volts theoretical value will be 3.7 milliamperes, practical value will be 3.69, approximately equal, right? Next, similarly vary the RPS voltage to 25 volts. And note down the corresponding ammeter reading, right? Theoretical value is 4.6, practical value is 4.63, approximately equal, right? Okay, that means Norton's current also verified theoretically and practically, right? Next, reduce RPS voltage to 0, right, and switch off the power supply, right? After that I can connect Norton's equivalent resistance circuit diagram, right? To connect this circuit diagram, here I can remove the ammeter terminals, right? After that remove the source terminals. Okay, we need to short the voltage source, right? That means we can connect this R1 point to again R3 point, right? Then I can connect one wire to resistance R1 starting point and this R3 that is connected to ground, right? Now across these two terminals, I need to calculate Norton's equivalent resistance. Okay, by using multimeter I can measure Norton's equivalent resistance. Yes, now see here. Yes, here Norton's equivalent resistance value will be 2.82 kilo ohms. Okay, you can observe here theoretical value is 2.7 kilo ohms, practical value will be 2.82 kilo ohm, approximately equal, right? Hence Norton's equivalent resistance is also verified theoretically and practically, right? That is about third circuit diagram, right? Next I need to calculate load current. Okay, this current should be equals to first current. This is from Norton's equivalent circuit, right? Now I need to connect this circuit diagram. Okay, for this circuit diagram I need two ammeters, right? Okay, this is first ammeter, this one is second ammeter. Okay, now see here, okay, for this circuit I need, this is Norton's equivalent resistance, right? It is Rn value. Theoretically this Rn value will be 2.7 kilo ohm, right? Then see here, first RPS positive is connected at one point. Okay, RPS positive is connected at one point. At that point ammeter positive is connected, right? Next, ammeter negative is connected at another different point. Okay, at that point Norton's equivalent resistance, that is 2.7 kilo ohm resistor is connected, and 2.7 kilo ohm resistor ending terminal is connected to ground. Okay, next, at this point only second ammeter positive is connected. This is second ammeter positive. Next, second ammeter negative is connected at another different point. Okay, at this point load resistance RL starting point is connected. Right, after that load resistor ending point is connected at another different point. Okay, next, RPS negative is connected to ground, right? Right, ground is having three terminals, 1 2 3. Right, now connections are over, right? Okay, now connections are made as per the circuit diagram, right? Switch on the power supply. Okay, switch on the power supply by varying the RPS. Okay, see here, by varying the RPS, here this one is Norton's current. By varying this RPS, here I need to measure Norton's current. Okay, Norton's current is flowing through the first ammeter. That means what is the Norton's current value? See here, for 15 volts, sorry, here Norton's current will be 2.78, right? After that I need to measure IL dash. Okay, that means by varying this RPS, current flowing through the circuit is, what is the Norton's current? 2.78, right? By varying the fine, I can get a accurate value. Okay, 2.78 means approximately 2.8. Okay, now see here, for this current, here theoretical value IL dash is 2.02, practically IL dash value will be 1.96, right? Approximately it is verified. Okay, similarly vary the Norton's current to 3.69, that means 3.7, right? Okay, for 3.7, for 3.7 of 3.7 milliamperes, the load current is 2.6 milliamperes. Theoretically it is 2.7 milliamperes, practically 2.6, approximately equal, right? Similarly, for Norton's current of 4.63 milliamperes, 4.63, right? Now I can vary this fine. Okay, for 4.63, okay, 4.7. Okay, for this 4.7, here IL dash value will be 3.27. Here 3.3 approximately equals to 3.27, right? Okay, in this way we can calculate load current. By adjusting RPS, we can set it to the Norton's current practical values. Okay, after that note down the practical load current. Okay, in this way we can measure load current by using Norton's equivalent circuit. Okay, after that gradually reduce RPS voltage to 0. Okay, and switch off the power supply. Thank you all.